Hello. I'd like to go over the exercise that we've been working on in class the past couple of days. And people made good progress on this, but I just want to make sure that we're all on the same page. So what we're doing is we're looking at the edit distance between two strings, and we filled in this dynamic programming table, so we've memoized all the possible substrings matching to other substrings of these two strings. As we were constructing the table, we also stored some information that allowed us to remember, well, which operations were it out of the three that we were considering that gave us an optimal cost here. So I started you off with some code that remembers that. So it actually has not just this costs array in this, what I call the table here, but it also has a moves array, which remembers it's going to be a 1 if cost 1, so deleting the last character from S2, or conversely adding a character to S1 is the cheapest. It's going to be a 2 if deleting the last character from S1 is the cheapest, and it's going to be a 3 if matching or swapping characters was the cheapest. Now the first thing I want to do is just find a single sequence that realizes this cost, okay? So yes, I have the cost, but I want to actually follow these arrows to backtrace and find a sequence of edit operations that realizes that cost. And there may be more than one. What I've done here is just broken the ties. So if there are ties, I'll take the arrow that goes to the left first. So that's the one where I'm adding a character to first string, or conversely deleting a character from the second string. If that is tied with, or if that does not happen to be the best one, then the next one I look at is the up arrow, and then finally I look at the diagonal arrow. Okay, so that's the order that I break the ties in. So let's just get one answer here. So what I have to do is start in the lower right, and so this table has m plus 1 by n plus 1 elements, where m is the number of characters in the first string, n is the number of characters in the second string. So I'm going to start at row at index m and j at index n. That's the lower right here, and I'm going to follow arrows until I get to 0. So I'll say, while it's not the case that I is 0 and j is 0, then I have to keep going. Okay, so a while loop is really the best choice here. Let me also make a list that I'll call path, and I'm going to store the cells that I visit on the way. Okay. So what I'll say is if moves ij is 1, then I know that I'm supposed to move to the left. So I'll say, well, first, I guess at the beginning of this loop, I better say path.append ij. So I'm going to make a list of lists. This is very much like you did on the cells where you found the average position. This could be a tuple, but I'll keep it a list for now. So, all right, so if I'm told that moves ij is 1, then that means the optimal decision here was going to the left. So I'll say j minus equals 1. Let me be super clear. J is equal to j minus 1. Otherwise, if it's the case that this is equal to 2, then I'm supposed to move up. And otherwise, I'm going to move both up and to the left. Okay, you understand this means j is equal to j minus 1. Okay, so I guess I will use the shorthand. All right, so let's just go ahead and print out the path that we get in this example. So I'm editing school versus fools, and we'll see if we can match it to that picture down there. And we get an error because we need to import some stuff. Okay, let's see. So 6, 5, 6, 4, 5, 3, 4, 2, 3, 1. So now we do 2, 1. So we actually went up this way. Remember I said we try the up first if there's a tie. Looks like there was a tie here. We tried the up before the diagonal, so we did 2, 1, and then 1, 1, same thing, and then finally we're done. So we don't store the 0, 0 because we know where we're supposed to end up there. Okay, I want to go a step further here, and I want to actually print out what the operations were if you were starting from scratch. Let's say that you were starting with the string school and you wanted to convert it into the string fools with either additions, deletions, or matches and swaps. What would you do? How can I express this path as a sequence of operations that would realize the optimal cost? Well, so the first thing is I need to reverse the path, because I started at the end and ended at the beginning, but I really want to be able to start at the beginning and see what I have to do until I match the whole thing. In Python, that's as simple as saying path.reverse. Okay, that reverses the list in place. So anyway, so that's fine. But let me actually do a little bit different. So what I'm going to do, instead of making instead of just storing these numbers, let me actually store some strings here that tell me a little more information. So what I'll say is, okay, if moves ij is 1, what that means is I'm at a particular cell, and really, it means that I'm deleting a character from the second string, but what that really means is I'm adding a character to the first string. So I'm going to be adding the character at index j in the second string to the first string. So let me say, I'll actually say path.append, adding, and I'll say, this character to S1. So that character would be S2 at index j, right? I better do that before I subtract 1 from j, okay. Otherwise, I'm moving down, which means that I'm deleting a character from the first string. Okay. So I'll say deleting this character from the first string. So S1 at index I. Otherwise, well, I have to look and see. I'm either going to be swapping or matching. So if the string, and I also better say, actually this is j minus 1, I minus 1, because we actually have that empty string, and we have that empty character in the front. Okay. Yeah, so I'm doing like what I did up here. Okay. So now I have the same if statement, and I say, okay, if it's the case that I was going diagonally, then I need to check to see if these characters were equal or not. If they were not equal, then I'm supposed to say swapping. So I'll say swapping some character for another character in S1. So I'm swapping in, I'll say swapping in this character for this character in S1. So I'm swapping in S2 at index j minus 1 for S1 at index I minus 1. Otherwise, I'm actually matching that character. If they're equal, I can just say that I'm matching that character. All right. So I don't need two things. I know if I'm matching, it's the same in both, so I'll just say one of them. Okay, and this should give me more information that I can actually interpret here. Okay, so let me actually say for step in path. So I reverse the path, print path. So these are strings now, not just numbers. So let's see what it told us. Oops, I meant to say print step. Okay, so how do we get from school to fools? That's what this is going to tell us. So from this path that we found, which I cost 4, first thing, swap in F for S. Okay, so I replace the S with an F. So now I have fuck cool. Okay. But then I'm supposed to delete the C and delete the H, so I have just F now. Match OO, so FOO, match L. And then add S. Nice, that seems to have done it. Okay, so let's pause and take a breath, and then I'll explain how we get all the paths. Okay, which is a nice little recursive trick using a stack.